Hello, everyone. We are welcome to the 10th class out of 16 classes for the introduction to SQL and Python in the data analytics course. So I'm going to share my screen now. Today, we are going to do a brief talk on table constraints in SQL and go into our demo part of things in writing SQL scripts. Okay, so this is a quick outline of what we'll be doing today. I'm going to make this full screen so everyone can see. Okay, yeah. So up until now, we've been looking at SQL not null constraints placed on tables. So constraints are ways of making your table to define the kind of data stored in them. So that way you can have much more defined or structured data in your values of data, right? So for instance, we have seen the way we use not null, saying that there must be no missing value in the given data set, right? So you can define constraints on columns. You can as well define constraints on multiple columns in your table data store, right? So we're going to look at some other constraints because we're going to use them in our demo session today. So I'm just going to show us what we already know on defining not null constraints. You can see that you can define it at the point of creating your table, just like we did in previous class. You remember the syntax for your SQL statement. For your create table, you simply create table, your table name. Our table name in this instance is students. Then define your column name. Our first column name here is ID. So maybe like student ID. Then this is the column type, integer. Then we define the null or not null constraint on our column. So you are familiar with this, but it's just to bring it to your remembrance that this is a way of defining constraints on tables, right? So this is not null. You can define not null on any type of column, right? So you can see it's defined on integer here. You can as well define it on a character type of column. It simply means that that column cannot contain a missing value. So if a record is to be inserted and there's no value for that column, the insert will not go through. So when collecting data, sometimes you can define these columns and it will also reflect at the point of data entry. For instance, let's say you are developing a data entry tool. The data entry tool is connecting to your database, right? So if there's a not null on that data, it will trigger an error message, which will show on the data entry tool that this record cannot be inserted. And I'm sure you might have experienced such maybe when filling some forms online or something. You would see that certain fields on your forms are asterisk as compulsory or required. So if you try to submit the form without filling in those values, there will be a triggered error saying form cannot be submitted. So at the back end of the database that is receiving the information for such a form has implemented a constraint like this at the back end, saying that, oh, if there is no value for that given field or for that given record, then do not accept it. So that's the essence of knowing how to define your constraints on your table And that's how it's applied in real life implementation. Right, so you can define the constraint at the point of creating table. You can also define it on an already existing table by using the alter command. Um, the alter command defined on your table will be used to change the constraint value on that table. So this is an example of how you can use the alter command to change your SQL not null constraint. Another very important constraint is the primary key constraint. In fact, primary key is widely used, and primary key constraint combines two-in-one constraints in the sense that when a column is defined as primary key, then the values in that column must be unique, and then it must not be missing. There must be a value. So a very popular example of primary key constraint is your serial number. So let's say you want every record in your table to be uniquely identified. You can just put a serial number to say, oh, okay, record one, record two, record three. So you can't have multiple serial numbers, right? Another interesting example is the ID. Many tables, when they define IDs, the IDs on those tables are usually a primary key. So a primary key uniquely identifies a record in a table, right? And you cannot duplicate values in a primary key, right? Now, a primary key can be defined on a column. A primary key can also be defined on multiple columns, right? So in a case that you want to define a primary key on multiple columns, then the combination of the values in all the columns must be unique. So for one of the columns, you might have repeating values, but the combination of it must be unique. An example can be, let's say, like your bank card. So in a bank database, you can have people with the same surname. You can even have people with the same first name, right? Because the bank database is housing millions, of customers, or thousands, hundreds of thousands of. So you might have same, especially names that are common. You can have an example of, let's say, surname. Think of the common surname, but let me just use a random surname. Let me say Ajayi. Ajayi is a common name. You might have 10 to 15 people within a bank database bearing Ajayi. Somehow, too, you might have same people bearing Ajayi and bearing the same first name. Might be maybe Tayo, some very common names like that. So you can have same Ajayi Tayo, same Ajayi Tayo. And something else would be unique about them, or might be unique about them. It might be their age. They might be of different age, or it might even be maybe their address or something like that. So let's say that table does not have a primary, it does not have a ID column, right? It only has surname, first name, and some other fields. And you are looking for how to uniquely identify the records in the table. In that case, you might want to combine surname, first name, and let's say age, or maybe height, or maybe color, or maybe some other thing that may differ slightly between them. So when you combine those three, you can make the three of them a primary key. So in defining multiple primary key, you can define it also at the point of creating table. You can as well define it at you can also define it on an existing table. These constraints as well can be defined using clicks, like user-friendly, just click method, like we did for creating table. But we all just need to understand the essence of these key constraints and how to use them. The next key constraint is the foreign key constraint. Now, foreign key is is not is not defined using SQL statement in a way, but in defining foreign key, you must have two or more tables. So, and each of these tables must have a primary key value. I mean, must have at least at least one of the tables must have a primary key. Don't worry, we are going to demonstrate this when we get to the demo part. So one of the tables must have a primary key. And then the primary key in that table must correspond to any field value in the other tables. This is what I mean in essence. So let's say you have two tables like we had in the table we imported. We had a list of customers table. We also have the sales made by these customers, right, in another table. So in the list of customers table, we are uniquely identifying each customer by the customer ID column, which is the primary key in customers table, right? And for us to know the sales made by each customer, in the sales table, you have a primary key as well, which is the sales ID. You use that to uniquely identify each sales. But you want to know the sales made by the customers. So in your sales table, you are going to include the primary key of your customer table, which is the customer ID. So you can see your sales orders table will contain a customer ID table, right? So the customer ID table in your sales orders table becomes a foreign key to this customer table, right? And this foreign key constraint is very important when defining or when merging tables. We are going to demonstrate it when we get to the demo part. So, and another interesting reason why we use foreign keys for defining our table structure is because it helps data retrieval from several tables to be efficient. So when you have several tables, you must have a way of linking those table information to each other, and to achieving that, you use both you use both primary key definitions and foreign key definitions in all your tables. Now, when you combine all these different tables together, right, it then helps you to define the table network, as the network, the relationship network between all your tables. And this is commonly called a data schema. I'm going to show us when we get to the demo, but I just need us to understand the concept. So you can just read what I have on the screen here. You can see the customer ID column in the customers table is the primary key, right? Then the customer ID column in the sales orders table is a foreign key in the sales orders table, and is a foreign key also to the table named customers table, right? So foreign key also helps you to prevent invalid data. So you want to ensure that for every sales orders, there is an actual customer to it, right? So to doing that, you have to use the foreign key, right? So that's the essence of foreign key and primary key definitions on tables. Then you also have the check constraint. The check constraint is used to limit the values, or just to place like a check on your columns. A popular example is, let's say you don't want age column to contain more than a certain age range, right? So you can place a check on such columns. You can also define, for example, now you define a gender column and you don't want any value other than female or male in that column, you can as well place a check on that. So this is also another way of ensuring quality in your data values that are defined. Then you have the default values constraint. Just like the name says, it helps you to set a default value on a column. Let's say that uh, for a column now, you have the date for the sales order. You don't need to start imputing date and you have different date formats, or maybe you have inconsistent date values. You can just place a default value, right? You can, or on such column, on such or you can even place character default values, right, on certain values, on certain columns. So these are examples. You can place default values at the point of creating your table, but you can't put it on an existing table that already has values in that column, except you drop the column and then create recreate the column again. So you can alter a table and create a new column with a default value. Right, so having defined your table with various constraints, you might want to check the existing constraints on the table. And to do that, there's a system table that enables you to do that. The system table is called the information schema table. Remember, we saw the systems table folder in our SQL Management Studio, and it contains some tables. So those tables are used for internal data storage and retrieval. And one of such examples is the information schema table. So the information schema table contains all the constraints defined on all the tables within that database. So to check the constraint defined on a given table, you just use this script on your screen and specify the table name. Unfortunately, there is a click method as well of checking the defined constraints on your table name as well. Then you can remove constraints that are on your table. Constraints are defined on tables, not on databases. So you should note that. So you can remove existing constraints on your table. But before you can do that, every constraint is created with a constraint ID defined in this information schema table, right? So for you to remove a constraint, you would need to retrieve the ID for that constraint using this script or using the click method, which I will show you later. And then you specify the constraint ID and the table name, and use the drop constraint clause on the alter table command to remove the constraint. You can also add constraint on an existing table using the alter table command, specifying the same constraint ID. So this can be used to create or re-add the existing constraint using the constraint ID. But of course, based on the previous examples I showed you, you can define a constraint using alter table command, right? So in defining constraints, you would not specify constraint ID, you would just specify the type of constraint. So that's that on constraints, which is an important aspect of defining your tables and storing your tables within SQL. And as we go along, we would need it. We would even use it very often. So it's important we understand it. And we'll go into our demo now and we'll see some examples of these various constraints. Okay, so that's the end of the demo. That's the end of the brief talk. See you in the demo session.